It was working earlier today. All right, so today we are going to, in 1-4 we talked about different angles. Now we're going to talk about the relationships between pairs of angles. Again, once again, I'll tell you where your notes are. If you have your notes printed out, it'll be very obvious. Okay, so we're going to be talking about angle pairs and finding information on a diagram. We already talked about that a little bit. And then we're going to talk about angle bisectors. We've talked about a bisector of a segment. Now we're going to talk about angle bisectors. All right, so some angle pairs have special names. And again, I'm going to go through them, and I'm going to give you time to break them in your notes. So if you want to start writing now, but if you give me a minute, I'll show your actual notes page. Okay. You can have vertical angles, two angles who are essentially across from each other. So 1 and 2 are vertical angles, and 3 and 4 in that picture are vertical angles. You can have adjacent angles. Two adjacent angles are angles that are essentially next to each other. They have a common side and a common vertex and no interior points. You've got complementary angles. They add up to 90 degrees or a right angle, and they're called complements of each other. You have supplementary angles that add up to 180. They're called supplements of each other. And then finally you have what's called, right there, you'll notice that those are two supplementary angles, but this is called a linear pair because together they make up a 180-degree straight line. So you'll notice in the supplementary angles, I have angle 3 and 4 here. Those are a linear pair and supplemental. The other ones, 75 and 105, those are supplemental, but not a linear pair. All right, so let's go through our notes here. Okay, so adjacent angles. Adjacent angles are two coplanar angles. They're in the same plane with a common side, a common vertex, and no common interior points. So again, you can look at our examples, angle 1 and angle 2, or angle 3 and angle 4. They have a common side, a common vertex, and no common interior points. And in English, adjacent just means next to. So that's what it means in geometry. Two angles are essentially next to each other. All right, the next ones we have are vertical angles. And vertical angles are, you can say they're across from each other, but the official definition are two angles whose sides are opposite rays. So if you look at angles 3 and 4 over there, you'll see that these rays makes up two opposite rays, these two straight lines, and this makes up opposite rays. So that's why 3 and 4 are vertical angles. I just remember it as two angles that are across from each other. Those are vertical angles, but again, the official definition are two angles whose sides are opposite rays. Okay, next one is complementary angles. Complementary angles are two angles who have measures that add up to 90 degrees. Each is called the complement of each other. So I have two examples over here. These two, 1 and 2, make a 90-degree angle because I got that special signal, or that special sign, excuse me, the little square sign in the corner. And then the other ones, angle A and angle B, 40 and 50, add up to 90. So I know that they are complements of each other, or they are complementary angles. And then finally, just like complementary add up to 90, supplementary add up to 180. So two angles whose measures have a sum of 180, and they're each called the supplement of each other. So adjacent angles next to each other, vertical angles across from each other, complementary angles add up to 90, supplementary angles add up to 180. Let's see if we can finish our notes in another 45 seconds. "15 seconds to finish up our notes. And again, obviously, if you don't finish these up, all this is in your textbook, or this presentation is up online. This video will still be up soon be up online, so you have lots of options of how to finish up your notes. If you have your notes printed out, I think you'd have them all done. All right, let's move on here. All right, let's do a couple of example problems. Use the diagram at the right. Is the statement true? Explain. So everybody try all of these. Try A through E on your notes. If you don't have your notes printed out, sure makes your life a lot harder, but take a look up here and see if you can figure it out and answer A through E. I'm going to give you guys 90 seconds to be able to answer all these, and we're going to go through them. Again, it's a great opportunity for you to check that you know the definitions and can figure it out. So 80 seconds, we're going to go through this. All right, let's go through these. So, BFD and CFD, are they adjacent angles? Well, they have a common side, right? FD is common to both. They have a common vertex, F. So, two of the three things we said for adjacent angles are true, but that third thing is not true. They do share a common side and a common vertex, but they have common interior points. It's an interesting way to spell have, okay? But they have common interior points. So you'll notice that FC here, these are common. So no. So I could say that BFC and CFD are adjacent, but those are not. All right, how about AFB and EFD? Are they vertical angles? And the answer is no. Why is that? Because FA and FD, those are opposite rays. There's my first part. But FB right here and FD right there, you can see they do not make a straight line. So no, they are not opposite rays. So these are not vertical angles. They're not across from each other. Okay, are AFE and BFC complementary? Well, AFE is 62 and BFC is 28. Add them up, you get 90. So yes, any two angles that add up to 90 are complementary. Which angle is supplementary to DFE? Well, the DFE, the supplement of DFE is X. DFE plus X is 180. That's what definition of supplementary means. How big is DFE? It is 118. So I find out, if I subtract, that X is 62. Which of these angles is 62? AFE is 62. So that's the supplement. You'll also notice that they're a linear pair, which we're going to go over in just a minute. And then finally, our which one? AFE, and CFD, are they vertical angles? And the answer is yes, they are, because if you look, FA and FD are opposite rays, and FC and FE are opposite rays. So they are across from each other. They are vertical. All right. Any questions on one? All right, see people getting these down their notes. Give you a couple seconds to get those down. All right, so moving on here. In your notes, we have a linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. They form a straight line. So if two angles form a linear pair, then they are supplementary. Right? They add up to 180. That's a linear pair. Okay, so it looks right here. So here's an example. KPL and LPJ are a linear pair. Why is that? Because KPJ is a straight line. So together they make up a straight line. They make up 180. Okay. Well, to do this one, I first have to figure out my equation. Oh, sorry. There's a drawing of a linear pair. Should have done that earlier. Sorry. Okay. So what I know is that KPL plus JPL together, they make up KPJ, which is 180. So now I can just substitute in, put in my values for x, combine my like terms, isolate x, and I get x is 20, and now I can just plug in. So KPL is 2x plus 24, so it's 2x's plus 24, or 64. JPL is 116. All right, so there's an example I did. I'm going to give you guys a minute to try example number 5. ABD and CBC are, BDC are a linear pair. Here are their values. Find the measures of them. So try that one. I'll give you a minute to get that done. ADB and BDC are a linear pair. No, it's a different picture. Or is it the same one? Let's see. Yeah, it's a different picture. This is just a picture. I drew this picture so you could see what a linear pair was. Yeah. All right. 30 seconds. We're going to go over this one. All right, so the key thing to recognize here is that if ADB and ADB and BDC are a linear pair, they add up to how much? 180, because if they make a straight line, they add up to 180. So I'm going to write that down, that these two together equal 180. Then I can just substitute in my values, 3x plus 14 and 5x minus 2. Now it's just algebra. Combine my like terms. Isolate x, divide by 8. And I have x equals 21, so now I can just plug in. ADB, as we said, is 3x plus 14. So that's 3 21s plus 14. That's 77. And so the other one's going to be 103. Obviously, you need to know the algebra, but the key thing here, as far as geometry is concerned, is that these two angles together add up to be 180 because they're a linear pair. They're supplemental. They make a straight line, and straight lines are 180 degrees. All right, let's move on. So we've talked about our various types of angles, including linear pair. So now we're going to talk about finding information on a diagram. Okay, we've already talked about this a little bit, but I want to go through this in greater detail. Okay, there's some relationships that you can assume are true, even if it has no marks or measures. Okay, so for example, you can conclude that angles are adjacent. Angles are adjacent, supplementary angles are vertical. So just by looking at stuff, you should be able to tell that. Okay, you cannot conclude that angles or segments are congruent. Just because they look like they're the same size, unless there's some sort of marking or some reason to tell you, they might not be. Again, you can't really tell the difference between a 1 inch and a 1.0001 inch segment. So unless it says that they are the same, you don't know that. Okay, you don't know an angle is a right angle unless it has a symbol. And you don't know angles are complementary unless they have, again, some sort of marking. Okay, so for this example, we know that angle 1 and angle 2 are the same because of the markings. Angles 3 and 5 are vertical angles because they just look like that's a straight line and that's a straight line. Okay, 1 and 2 are adjacent, 2 and 3 are adjacent, 3 and 4 are adjacent, 4 and 5 are adjacent, and 5 and 1 are adjacent. And finally, what we know is that 3 and 4 together make up a linear pair, so they must be supplemental. And 4 and 5 make up a linear pair, so they must be supplemental. That's all we can tell on that particular diagram. Okay? So here's what you can and cannot assume. Here's a diagram. What you can assume on this one is that AC is a straight line. D is in the middle of it. And so ADC is a straight angle. ADC are collinear, and D is between A and C. That's it. That's all you can assume from this diagram here. You can't assume that whatever these two angles up here are the same. You can't assume these angles are the same, even though they look like it. You can't tell. Okay. What you cannot assume, okay, again, you can't assume that any of these sides are congruent. We don't know. You can't assume that D is the midpoint. It sure looks like it, but we don't know that. You can't assume that the angles are congruent. You can't assume that this is perpendicular. You can't assume these are right angles. Okay, so again, you get used to what you can and cannot assume about diagrams. Okay, so, and here's why. Because all the time, in geometry, we'll say, okay, draw a triangle, and you draw a triangle, and then I start telling you stuff, and I say, okay, this side here is 5, and the 3 angles are congruent. See how they have the same symbols. So this is a fine drawing for what this is. However, what it actually looks like is that, right? If the 3 angles are congruent, they're going to look like that. But you could be given a diagram like this. This diagram is perfectly fine because it tells you, it shows you in symbols that these angles are the same, and you can't assume that these different sides are the same. Okay, so again, it gets confusing. You look at this, and it actually looks like this. Okay, let me give you another example. I'll say, hey, draw a quadrilateral, 4-sided figure, and they've got 3 different sides, 4, 5, 7, and 12. Okay, so you might draw it like this. Obviously, that's wrong. If you were to actually draw it, it would look like this. But this is fine. Because, again, I have my numbers here. I know what the actual things are. And I can't assume that these are right angles, so this is fine. Okay, so let's go through in detail in your notes what you can and cannot assume. So, again, these are in your notes. So what you can assume are straight lines. Again, if you got a line, it's a straight line. If you got multiple points on it, they're all on that line. So straight lines are straight angles. The collinearity of points, like I said, if all these points are on a particular line, they actually are. You can assume vertical angles that they're across from each other. You can assume adjacent angles that they're next to each other. And you can assume supplementary angles that they add up to 180 if they're on a linear pair. So just that stuff you can just assume about a diagram. And there's some things that look true, but you cannot assume. So for example, if it looks like a right angle, unless it says 90 degrees, it's got the right angle symbol, it may or may not be, you don't know. Complementary angles. So again, if 2 things add up to 90, you have to make sure they actually do. Congruent angles. Again, if 2 angles look like they're the same size, Maybe they are, maybe they're not. We don't know until we can figure it out. Same thing with congruent segments. They may or may not be the same size just because they look like it. Sure. I'll put it back as fast. Thanks. Okay, so if you want information about a right angle, complementary angles, congruent segments, or congruent angles, the diagram must be marked or information must be given. So it doesn't mean that two segments can't be equal, obviously. It just means that they have to have common markings, or they have to have, they both say they're 3 inches long, or whatever. Some way the information is given that indeed they are the same. Okay, so what can you conclude about this diagram over here? Okay, what you can conclude is that angle 1 is congruent to angle 2 because they're adjacent. We can assume adjacent angles. It says so here. Okay, 3 and 2 are vertical angles. No, they're not. What the heck? 3 and 2 are not vertical angles. 2 and 3 are adjacent angles. Sorry, that should say adjacent. 4 and 5 are a linear pair. So again, I'm sorry about this one. 2 and 3 are not vertical. 2 and 3 are adjacent. Sorry. 4 and 5 are a linear pair. And therefore, they're supplementary angles. 4 and 3 are a linear pair. So they're supplementary angles. And then I've got all these different angles are adjacent. So oh, I see. This is supposed to say 3 and 5 are vertical. There we go. 3 and 5 are vertical angles. Okay, so 3 and 5 are vertical angles. Okay, then that's it for what we can assume, right? It sure may look, for example, that whatever 3 and 4 are equal angles, but we can't just assume that. All right, what can we conclude about the information in the diagram to the right, for example, 3? Well, TV is congruent to VW. Why do we know that? Because we have the symbols right there. We have the symbols. What else can we conclude? That W is the midpoint of TV, because the definition of midpoint is that it cuts the segment in half, and these two segments are congruent. So we can assume that this segment is equal to this segment. Okay. And PQ bisects TV. It's another way of saying the same thing. Okay. But that's it that we can assume. We can't assume that, for example, PW is equal to WQ. It looks like it. We can't assume that that's true. Right? The only things we can assume, because the only markings we have are these two tick marks. So we know that TW is equal to WV, which means that W is the midpoint and means that PQ bisects it. Okay, and the final thing we're going to go over is an angle bisector. Just like a segment bisector cuts a segment in half, an angle bisector divides an angle into two congruent angles. Its endpoint is at the angle vertex. Okay, so an angle bisector is a ray that divides an angle into two congruent angles. Its endpoint is at the angle vertex. And then here's the example in this particular diagram. Angle XAY and angle YAZ are congruent. Therefore, AY is the angle bisector of XAZ. And notice that it can be either a ray or a segment to bisect the line. It does not have to be a ray. It doesn't have to go all the way. It can just go part of the way. All right, a couple quick questions here. So, if AC bisects DAB and DAC is 58, what is DAB? So I drew an example for us. AC bisects DAB and DAC equals 58 degrees. So we have to figure out how big is DAB. Well, to do that, what I would know, if that's 58, the question is, how big is that one? Well, that one would also be 58. So together, they're going to add up to DAB. 58 plus 58 equals 116. The key thing is, how do I know that BAC is 58? Because it's the angle bisector. They're the same measure. Okay, the next one. KM bisects JKL. If the measure of JKL, so that whole thing is 72, how big is JKM? Well, I'm going to call that X. JKM is X. And if that one's X, then I know that this is also X. Because again, they're the angle bisector. They are the same measure. So I know that X plus X equals 72, or 2X equals 72, or X equals 36. So I know the measure of JKM equals 36 if it's an angle bisector.